Okay, on the blue color board, we're going to write down this example, solve by grouping. This is done when we have 4 or more terms. The first step is always the same. On your global, on this left column, we're doing step 1. Sebastian? Oh, let's check for GCF. So let's look. 35, 30, 42, 36. We use near. What is the greatest common factor between those coefficients? For the little line right here. 35, 30, 42, 36. Is it 1? What goes into both 35 and 30? 5 and? Is it just 5? Yeah, just 5. Is 5 going to 42? No? 1? Yeah, probably smart boy, probably. But I'm teaching, so I'm not going to answer it. Okay, so, greatest common factor for the coefficients was 1, but what about the x's? Does the last term have an x? No. Last term does not have an x. Okay, so our greatest common factor is 1, so we're not going to factor anything out. So factoring by grouping looks like this. What we're going to do is group the first 2 and look for their GCF. But there's not a GCF other than 1 for all 4 of them, but what about the first 2? Well, in terms of neighbor and tell the GCF is not 5. And your neighbor tells them the GCF. Allison? You might go to someone else that doesn't want to talk to? Alright, Anthony, what's the GCF? Good, okay. Like my bell. I don't know what it is. 5x squared. It's not just 5, but it is 5x squared. And when you said x squared, don't need to say x. Yes, they both have x's. The smallest quantity of x's is x squared. Okay, so you divide both by 5x squared. That's what that thing does, right? You're factoring it out, because it's the inverse of distributive property. So we distribute, we multiply, we factor, we divide. Okay, so 35x cubed divided by 5x squared. Making what's that going to be? X, right? Because 3, take off 2, gives you 1x. Okay, let's see. Rosie, what about the last one here? 3x squared divided by 5x squared. Because the x squared cancel out, right? So we have plus 6. Really, 6 times 1, that's just 6. Okay, now we're going to do the other 2. Grouping the other 2. Make sure you take the sign, especially with the minus, it's very important to get the sign. Okay, between these 2, tell your neighbor what the greatest common factor is. Between 42x and 36. Here are all the right answers. And what do you have? 6. Good. Positive 6. So, we're going to divide it out and write what's remaining. Now, here's a hint for you. Here's a hint. When you divide that first term, the x should always be positive. So if you're dividing as a negative, that means you probably should have taken a negative out. Okay, so when we divide it, make sure it's positive. 42x divided by 6, is that going to be positive? Yeah, so we're in good shape. That leaves us with 7x plus 36 divided by 6 is 6. Oh, look. Matchy, matchy. Does that match? I like that. Okay? That thing is something that they have in common. We know it's something in common. What they have in common is the match. 7x plus 6. If I take off, watch me again. If I take off 7x plus 6, what does it leave behind? 5x squared. If I take off 7x plus 6, what does it leave behind? 6, positive 6. So there is your factoring form. That's factoring by grouping. So one of them is the match. The other one is the outside JCS. Okay? So, if you do a packet, I have one example on your foldable, and we're going to work some of these factoring problems, factoring those tests. So you make sure you're comfortable. What? Make sure the color is mine. No, pink. Shows it here. Transfer the light. When you fold up your foldable, and on the blank side, it doesn't say factory, you can put your name and class period. Keep your foldable out, though. Don't put it away. Use your name and class period on it. When you fold up, the blank side. One side says factory, do it on the other side. Your first and last name and your class period, yeah? Yeah, we're going to do it. Once it comes fast out, I only do one thing at a time. Alright, we are going to start with number 2. The first step is always the same. If you always forget the steps, you have a foldable now to refer to. The first step, no matter if there's 2 times, 3 times, or 4 times, is always the same. Always check for a what? KCF. With your neighbor, would you look through that and see if there's a grand contact that I can get pulled out? Your calculators, I know it's a big number, divide them out. And it's the greatest. Not just any factor, it needs to be the greatest factor that goes in all of them. It's the largest number that divides into 40, 64, 120, and 192. So do that yet, because we're going to factor out something. You don't grab them yet, because this one has a GCF. The answer here, when you find it. What's the GCF? There's a bigger one. Yes, there's a bigger one. Bigger than 4. It is an 8. So first, before we group, we're going to pull out the 8. I would put brackets, because I use parentheses for the grouping. You can use all parentheses if you want. And each one of these, we have to divide by 8. Do they all have p's? No. So we can't take out p's off of all of them. We can take off an 8. Let's see, what is 43 cubed divided by 8? 9 p cubed, okay? Roberto, about this term. Can you simplify the second term? You don't need a calculator. It's part 64 divided by 8. 8 times 1 is 64. That's 56. So we go higher. 8. 8. What's the rest? Right there, what's the rest? P, how many P's? P squared. There you go. Okay, let's figure out the third term. We can do that. Okay? 15P. Good. And who's in on the last term? Last term. Really. 24. All right. After you have done that step, and you have 4 terms, you only do this method if there's 4 terms. After you've done that step, we factored out the GCF. Now we're going to group the first 2 within my brackets. Okay? Find another GCF. 1 P squared. 5 and 8 degrees come back as 1. They have P squared. The 8, don't forget about that. Those things out to the very end. You can use either. They're both just a photo grouping, but I put brackets on the outside to help my eye see the differences. So I put brackets in or they're in parentheses. And this helps my eye see where the actual groups are. Okay, Drew, if we take off P squared from both of these terms, what would you left? Is that okay here? 5P cubed divided by P squared. So we take off 2 P's. What's left? What about 5 of those? 5 still there? 5P plus 8P squared divided by P squared. P squared divided by P squared. Doesn't that cancel? So we just get 8. Okay. Now we're going to group straight and define the next 2. Turn to your neighbor and tell them what you think the GCF is. Turn to your neighbor, take it and see to the neighbor. Pick one, pump back, side, side. Alex, would you tell neighbor? The largest number is divided 50 and 24. What is Alex? 3. Do they both have P's? No. So positive 3. If we divide both of them by 3, okay, Allison, can you simplify this one? 15P divided by 3. Good. And what is the last one, Allison? Divide by 3. 8, yeah. Oh, look! Here it comes. Matching. Get a match. That means you're on the right track. 5P plus 8 is one of the factors. Remember how I told you the other factor came about? What's the other factor? P squared plus 3. And then something so easy to forget about was at the very beginning there's a third factor. The 8 just tags along until the answer comes out. Okay? Any questions before you try one on your own with a partner? Okay, with your neighbor, you're going to try to do the whole thing. Number 3. First step is always the same. Factor out a GCF. Greatest common factor. What with the neighbor? Number 3. The GCF has to come out of all 4 of them. Before you put parentheses, you need to factor out GCF. Goes on. And you get a match. That's a good sign. You're on the right track. So did you do that? Okay, we're just almost. The 7's not. Because negative 14 divided by 7 is negative 6 feet. And we want positive 6 feet, so we're going to put out a negative 7. Which means this is minus. Good. Okay. At the beginning, these in the air. What was the GCF of all 4 of them? These in the air. What was the GCF of all 4 of them? Well, there is always one thing. 1. So we're not going to put anything out because it's 1. So between the two of them, just see what's that GCF. 3. There we go. You know, 3b squared. And we divide. So tell what's remaining. Okay, I agree with that. Now, careful over here. Remember, between 42 and 35, it's a 7. But if you plot a 7, if you plot positive 7, you're left with negative 16 minus 5. Does that perfectly match? No, because I told you we need this B to be positive over its match. So we plot a negative 7, which makes us positive and positive. And we have matchy. I know you guys think it's silly, but you really remember it. 6b plus 5. You can tell me the second factor, Rosie. Minus, what is minus? So the 5 is inside, so this one minus 7? That's the outside, right? 3b squared minus 7, so the matchy, and then the outsides. Okay, let's flip over to the back, number 11. And then we're going to get to a game where candy is involved. Yeah, you can handle number 11 well. Flip it over to the back. Because we don't just do factoring like working. We also factor trinomials and binomials. But we already did one binomial today. Okay, no matter, we'll chatty. No matter what type of factoring problem it is, whether it's 2, 3, or 4 terms, the first step is always the same. Look at the GCF. So, hands in the air. one factor, but it's just one. We should always check that. Now, if you've forgotten how to factor a trinomial, look at your little boxes. 3 terms, open the secret door. What method do we use? Tic-tac-toe. So please draw a tic-tac-toe to 11. Okay, on the top, look at the labels. We've already done one of these today, so it should hopefully be fresh. Or you have the tic-tac-toe reference in your foldable. Okay, Haley, what are the labels that we put across the top? Great. A, C, A times C, and we're adding to B. Okay? And B. What did I put here? Good. Drill. What did I put here? Good. Now when we multiply, not something big. You know, the product. 225. Okay? Yeah, what goes here? In the B position. Good. I'm glad you said negative. It's important that we take the sign with it. So, these last two numbers you wrote down tell you something about what we're going to plug in. If it multiplies to positive, both are positive or both are negative. And we're adding to negative, so that tells you both numbers have to be a negative. So lesson was 225 and adds to negative 30. If you don't know, you do this and you divide. So you find it. I don't know who's first. You got it. Okay, I'll read. Oh, it was times, oh yeah, they don't have to be negatives. Does that work? What's the square root of 225? What's the square root of 225? 15. So 15 times 15 is 225. So in order for us to add to negative, they're both going to be negative. The negative times negative is positive, so it works. And at the bottom left-hand corner, what do I always forget to put in the first column? X's. Okay? Jake, what's the greatest common factor between 9 and negative 15? 3. And we have 9 and negative 15, so we have another 3. Okay? Palmer, what about 25 and negative 15? What's the UCF? Negative 5 in here. Okay, let's make sure times work. 3 times 3 is about positive 9. Negative 5 times negative 5 is about positive 25. 3 times negative 5 is about negative 15. 3 times negative 5 is negative 15. So, after those diagonals, 3x minus 5. Why do we say squared? They're the same. So you can write that, but I like this version better. X minus 5 squared. Squared like that. Okay. You ready to be tested in teams? You can't be on the line.